Now in the force, we have seen so what is your Prince, is force a scalar quantity or vector quantity?
Sir, I'll be right back.
Okay. Prince, is force a scalar or a vector quantity?
Sir, scalar.
Is it okay? What are scalar quantities? Prince, what are scalar quantities?
Quantities.
Yeah. What quantities are called as scalar quantities?
Uh, Sir, which have no direction.
Which have no direction. Okay. So do you think force has any direction or not?
Yes, sir.
So if it has direction, so it should be a scalar quantity or a vector quantity?
Sir, vector.
Vector quantity. Okay. Force is a vector quantity. So, okay, Harini, can you name some of the vector quantities?
So velocity,
Okay, velocity and
weight,
okay,
displacement.
okay, very good. So you know about scalar and vector quantities. Now, which law of motion defines force? Which law of motion?
Sir, is it the first one?
The
Inertia.
first law. Yeah, the first law it defines force. Okay. So according to the first, can you state the first law of motion? Aman, Aman, can you state first law of motion?
Sir, can I?
Yes.
Sir, object.
Sir, did you call me?
Yeah, I did call you. I asked you that if you can explain me the first law of motion.
Yes, sir. If an object is in
Mhm.
rest, it'll stay in rest. If an object is in motion, it'll stay in motion unless an unbalanced force acts upon it.
Okay, in the first law of motion, it states that a body okay, every body will continue to be in its state of rest or of uniform motion. Okay, so every object or body, so give the proper definition, right? Will continue to be in the state of continue to be in the state of rest or of uniform motion in a straight line. Unless acted by an external unbalanced force. So if you have an external unbalanced force, then only the state of the object will change, else it will remain the same. An external force. So what about the internal forces? Can the internal forces bring about any change in the state of motion?
Sir, what do you mean by internal forces?
Okay, internal forces means suppose if you are sitting in a bus, and while sitting in the bus you are trying to push the bus. Okay.
Okay, sir.
So for the bus and you are applying an internal force. So can the internal force bring about any change in the state of motion?
Sir, is the internal force greater than the external force?
See, the internal forces, they cannot bring about any change in the state of motion. Okay. The internal force, like you can't push a bus while you are on the bus. To push a bus, you have to get down the bus, right?
Oh, okay, because the bus is moving you cannot move it backwards.
Yeah. Suppose if you are, can you do that sitting on a bicycle? You are trying to push the bicycle without touching the ground.
No, sir.
No. Okay. So here it's only that unless there is an external unbalanced force, you cannot bring about any change in the state of motion. And any change in the state of motion, understand this also concept. That means if an object is moving with a uniform, with some velocity, so its velocity will remain constant. It will continue to move with that velocity. There will not be any change in the velocity also. Okay. So that is why all the objects in the solar system, they continue to move in the straight line unless they are acted upon by some gravitational forces of Earth or any other object. Okay, like there are number of meteors and meteorites which are flying around in the flying around in our universe. Okay, so if any of them comes very close to the Earth, it may get attracted towards the Earth and hence hit the Earth, becoming a meteor or a meteorite. Got it? So they are continuing to move in their straight line. All the objects, they continue to move in their straight line. Okay, understood this? First law of motion. Then you have another term, that is inertia. Okay, so now who will explain about Orosmith? Orosmith, can you tell what is inertia?
Natural tendency to
The natural tendency.
the natural tendency to be continue in the state of motion.
Okay. So inertia is, it is the tendency of an object to resist any change. All of you turn on your cameras now. Prince, Harini, Rishika, Aman, Orosmith, Chavan. All of you turn on your cameras. Okay. So inertia is the tendency of an object to resist any change you just wait for 1 minute. Okay, so thank you everyone for waiting. And so we were talking of inertia. Chavan, you have written about F equal to ma. That is not inertia. We come to inertia first. So the tendency of an object to resist any change in the state of motion. In the state of rest or of uniform motion. Straight line. Okay. So the tendency of an object to resist any change in the state of rest or of uniform motion in a straight line is called inertia. So what is inertia? Inertia is the natural tendency of an object. So all the objects, they have a tendency to oppose any changes in their state of rest or of uniform. So generally what we observe, here in this case, our observations are different from what is given over here in the in inertia. Okay, we observe here that all the objects, they cannot continue in the state of motion. Okay, can the objects continue in their state of motion without any force? Yes, Aman. Aman. Smith.
Yes, sir.
Can an object continue in a state of motion or uniform motion even if there is no external force?
Yes, sir.
So how it is possible? We do not see anywhere. Do we observe it anywhere that you do not apply any force and still the object is moving? It continues to move and doesn't stop. This is what is stated by the inertia. But
Sir,
have you?
can
Yes,
I tell? Sir,
yes.
because there is frictional force that applies on
Friction.
Earth, we won't see anything on the Earth that can move on its own without external force. But in the universe, you find all the planets moving around the sun without any external force.
But they are applied by a gravitational force.
Okay.
Hmm?
But if
See,
there's no frictional force, then the object won't stop moving.
see. Of course, you are a little bit, you are correct in the beginning, but your example was incorrect. Okay. Your initial explanation was correct that on the earth it's not possible to observe an object keep moving to observe an object to continue moving without any external force, since all the objects, they offer a little bit of friction. Okay, so you will observe objects to be stopped. So all the objects, they will stop after some time when they are moving. They cannot continue to move with uniform motion. There will be a change of velocity. Okay. But what happens over if you go into the space? So into the space, if you kick a ball, the ball will continue to move. It will never stop unless there is an external force. Okay. So unless there is an external force, there will not be any change in the velocity of that ball. Got it? So this is what we have inertia. Like you have that. Okay, let's see. That's a different concept. So I hope you have understood about inertia. That if an object is moving with a constant velocity, so there is no external force required for an object to continue moving with a constant velocity. Okay. We will see a very important question coming from the concept of inertia in the coming classes we will have. Okay. So this was about the inertia, and so Aman is there. Aman. Okay. Chavan. Okay, Chavan. What are the types of inertia? Yeah, Chavan, what are the types of inertia?
You mean movement wise, like inertia at rest, inertia in motion, inertia in one direction. Do you mean it like that?
Yeah, we have inertia of rest, inertia of motion, and inertia of
Inertia
direction. So inertia of rest, inertia of
there
motion, and
it's
inertia. Yes.
one direction.
Okay. So these are the three types of inertia: inertia of rest, inertia of motion, and inertia of direction. So these are the three types of inertia. Then we have studied about the second law of motion. So up to now we did the first law of motion. Let's see the second law of motion. What does the second law of motion state? And so, Rishika, what does the second law of motion state?
Sir, F equals ma, sir. From
No, give the statement of the second law.
Sir, is it force is the rate of change of momentum?
Yes. According to the second law of motion, the force is proportional to the rate of change of momentum. The force acting on an object is proportional to the rate of change of momentum. Okay. So now we also need to study about momentum. What is momentum? Yes, what do you mean by momentum? Prince, what is momentum?
Sir, mass and velocity of object.
Okay. It is the product of mass and velocity that we call as the momentum. Okay. So the product of mass and velocity is called as the momentum. And is momentum a vector quantity or scalar quantity?
Sir, vector.
Okay, momentum is a vector quantity. So in what is the direction of momentum? How do we take the direction of momentum? Yes, anyone else? Aman? Chavan?
Yes, sir.
Yeah, how do we find out momentum? And is it a scalar or vector quantity?
Sir, momentum is a vector quantity.
Very good. And how do we compute?
Wait a second. Sir, give me a minute. I forgot.
But just now he told, I think Prince told that.
He did. I wasn't paying attention, sir. Sorry.
Okay, so that's very good. Okay, Aman, how do we compute momentum? Aman,
Yes, sir.
how do we compute momentum?
Um, Sir, I forgot.
Okay. So can you see the screen?
Wait, is
Yeah.
it P equals MV? Yeah.
So what does P stands for? What does M stands for? What does V stands for?
Sir, can I tell?
Yes.
Product of mass and velocity.
Okay, the product of mass and velocity is called momentum.
Yes, sir.
Okay. So we find it by multiplying mass and velocity. Okay. And what is the direction of momentum? In which direction do we take momentum?
So direction of force.
Direction of force? No. What is the direction of momentum? Or Smith was telling. Prince, what is the direction of momentum?
Sir, has same as velocity.
Yeah, same as velocity. So it acts along the direction of velocity. See, everything is written here in this on the screen. You can tell it by reading through the screen also. Okay. So what is momentum? The product of mass and velocity is momentum, where we have the formula P is equals to mass times velocity. And what about mass? Is mass a scalar quantity or a vector quantity?
Scalar.
Yes. Yeah, mass is a scalar quantity and momentum is a vector quantity. So momentum act along the direction of velocity. So whatever direction the velocity is, that is the direction you have the momentum. So momentum act along the direction of velocity. Then the SI units of momentum. Chavan, what are the SI units of momentum?
Sir, is weight one of them?
No. Weight is not one of them. Okay. Can you see the screen and tell what is the SI unit of momentum?
Kilogram.
Kilogram meter per
Okay.
second. Okay. So Chavan, you are not paying attention now.
Is that the only SI?
Yeah. See the formula of momentum is the momentum is given by P equals mv, and hence you can write the SI units of momentum will be mass taken in kilogram and velocity taken in meter per second. So kilogram meter per second, this is the SI unit of momentum. You can also write it as kg ms minus 1. So this is your momentum. Here in inertia, we are actually talking of the momentum. When we say that the object, the tendency of an object to resist any change in the state of rest of or of uniform motion. So we are trying to say here, we cannot bring about any change in the momentum. We cannot bring about any change in the momentum of an object. So momentum is what that measures the motion of an object. Here we say resist any change in the state of rest or of uniform motion. So that motion is measured by momentum. The momentum of an object, it determines the uh, motion of an object. Okay. So understood the quantity momentum?
Yes, sir.
Okay. Now let us see here we have the third law of motion. Sorry, second law of motion. Okay, we complete the second law of motion. We just now studied about the momentum. So according to the second law of motion, the force acting on an object is proportional to the rate of change of momentum. So you can write here force proportional to change of momentum over time. So here delta P represents the change of momentum and delta T represents the change of temperature. So we can say here that the force is proportional to rate of change of momentum. So that means the greater the change of momentum, a greater amount of force will be required. If you want to bring about a large change in the momentum in a small interval of time, so some amount of force will be required or a large amount of force will be required. Okay. So let us try to understand this concept, and from here you also have the formula. You get the formula here that you get here force is proportional to or force is proportional to delta P by delta T, where delta P represents the change of momentum and delta T the change of time. So we can write here force proportional force equals to mv minus mu over t, okay, where mv minus mu divided by the time represents mv minus mu represents change of momentum, mv represents the final momentum, mu represents the initial momentum, and t represents the time. Okay, now let us see. I give a small question and you try to find out here. Football player kicks a football weighing 750 gram. Okay, so football player kicks a football weighing 750, sorry, 950 gram. Weighing 950 gram. Let's see. I have some. A football of mass 950 gram is moving with the velocity of football of mass 950 gram is moving with a velocity of 15 kilometer per hour. Sorry, let's say 18 kilometer. So football is moving with a velocity of 15 kilometer per hour or 18 kilometer per hour. Sorry. Yeah. Yes, Chavan, what are you doing on the beach?
There, no, it's just a background.
So you are taking the benefit, you are moving here and there. Okay. See, a football of mass 950 kilogram is moving with a velocity of 18 kilometer per hour. Find its momentum. So find out its momentum. You have to find the momentum. Find out the momentum. So have you found out? Who all have found the answer? You have to find the momentum.
Sir, I have a question, sir.
Yes.
Sir, do we have to convert 950 grams into kilograms?
Yeah, you have to.
Okay.
So since you have to use the SI system of units, so you have to convert it to meter per second and kilogram. Okay. So you have your three questions. First of all, you have to find the momentum before the ball is hit by the player. Second, you have to find out the momentum after the ball is hit by the player. And third, you have to find the force applied by the player if the ball was in contact with the player for 0.4 seconds. Is there someone who has left the meeting? Prince. Okay, who has got the answer for the first one? Prince, can you explain how do we do first part?
Sir, equals to M into V.
No, first part. See, what do you have to calculate in the first part?
Sir, before the ball is
See,
hit by the player.
read here. Here it's the part A. Read part A of the question.
The momentum before the ball is hit by the player.
So what do you have
I
to
got
find out?
4.51.
Okay.
I got
What do you have to
4.5.
There it will be 4.75.
Okay, just
And for
1
B, it
minute.
will be 9.5.
Yeah, Prince.
Yes, sir.
Yes, sir.
Prince, what do
Sir,
we have to
momentum.
find out? Momentum. And what is the formula of momentum?
F equals to MV.
F equals to mv, right? So we will be using the
Yes.
formula F equal to mv. F equal to mv or P is equal to mv?
Sir, P.
P. Okay. So you'll write here P equals to mv. And what is mass?
Sir, 950 gram. So 9.5 kg.
9.5 or 0.95?
0.5.
0.95.
Yeah, it will be 0.95 kilogram multiplied by the velocity. So what will be the velocity?
1000.
Sir, 18,000.
18,000. 18,000.
No, not 18,000. Convert this to meter
Five.
per second. I told you the
Sir, 5,
shortcut
sir.
method.
5.
The shortcut method how you can convert kilometer per hour to meter per second.
Sir, our
Multiply
answer
this
5 by 18.
number by 5 over 18. Okay, so remember this trick. Multiply the number by 5 over 18. Okay. then you will get it in meter per second. So how many meter per second are you getting for 18 kilometer per hour?
5, sir.
5.
Sir, 5.
Okay, we get here 5 meter per second. Prince, are you getting?
Yes, sir.
Okay, understood this now? Every time you have to convert from kilometer per hour to meter per second, multiply it by 5 over 18.
Yes, sir.
So you have 5 over 18. If you multiply, you will get your answer equals to 5. Okay. So multiply this 5 and 0.95, you will get your answer something as 4 point something you will be getting. Yeah, what's the answer you are getting? It's 4.75.
4.75
So you get here
kg meter per
4.75
second.
kg meter per second. Aman, did you get the answer?
Yes, sir.
Aman, okay. Now the second thing you have to find out that momentum after the ball is hit by the player. Okay. So what will be the momentum after the ball is hit by the player?
Sir, 9.5 kg meter per
9.5.
second.
Okay. Again, the same method. Now you will convert this 36 kilometer per hour to meter per second. So, Prince, how many meter per second will it be if you convert it to meter per second?
Sir, 5.36.
Yeah, it would be okay. Okay,
5.36.
okay. Do it and check. Do it and check.
Yes, sir.
Take your time. Okay,
Sir,
take
I
your
got
time.
0.95 kg.
Okay. So your P2 will be 0.95 multiply with
By 10.
find the velocity. How
Multiply by
much you are getting?
Sir, I'm getting 10.
Yeah, Prince, did you get the answer or not?
Yes, sir.
See how convert this, you multiply 36 with 5 over 18, right? So if you multiply 36 with 5 over 18, you can see 18 cancels this 36 two times, and 2 times 5 will be equal to 10. So that is how we get here 10 meter per second. Got it? So understood the answer to the part A and part B. Part
Yes,
A,
sir.
part A is 4.75, part B is 9.5, and you have to find out part C, the force applied by the player if the ball was in contact with the player for 0.04 seconds. Okay, so Orosmith is here. Orosmith? No, Orosmith is not here, right? And we have Aman, Harini. Okay, Rishika. Which formula to be applied now?
Sir, F equals MA, sir.
F equals to ma, or can
Yes,
we
sir.
also use this formula change of momentum over time?
Sir, which one, sir?
We have the direct here change of momentum over
Yes,
time.
sir, we can use that too.
We can use either this formula, force is equal to change of momentum over time. Okay.
Yes, sir.
Or we can use force equals to mass into acceleration. Okay. So if you find out here, our net force will be equals to mass into acceleration. So we have to find out the force. We know only mass, we do not know acceleration. So to find out acceleration, you will use the
Sir,
first
we can do
equation of motion. Yeah.
alpha t by alpha t.
Uh, how much you are getting?
Sir, we can do it by alpha p by alpha t.
Yeah, that's what I told you.
I'm
Either you
getting,
can you
I'm
can get
getting
here
like,
change of mv minus mu over t. You can get it like this. Final momentum we have got 10.
I
Sorry,
got
9.5.
118.75 newtons.
See, you will be getting something like this.
Sir, I got the same
9.5
answer.
minus 4.75 divided by 0.04. So you get here 4.75 divided by 0.04. You have 475 divided by 4. Okay. So are you getting this answer? 475 divided by 4.
118.75 newtons.
118. Okay. You get
0.75.
here 118.75 Newton. Okay. The same thing or the same question can be done something like this also. You can find out acceleration first by, since initial velocity was 5 and final was 10. So you make 10 minus 5 divided by 0.04. So you get 5 divided by 0.04. And this would be equals to 500 over 4. That is 125 meter per second square. So this is acceleration, and now you can use the formula F equals to ma. So by both the methods you will get the same result. Okay. So can we do one more question now? Yes. Can we do another question?
Okay, sir.
Okay. Yes. Yes. What happened? Anyone having any doubt? Can you people turn on your cameras, all of you? I think Prince video was stuck, so that's why I thought. Okay, let's see. You have here a trolley of mass a trolley of mass 500 kilogram is pulled by an engine by a horse. So the horse can apply a maximum force so the horse can apply a maximum force of 1000 Newton. So you have to find the acceleration of the trolley. To find the acceleration of the trolley.
Sir, 2 meter per second square.
How much?
Sir, 2 meter per second square.
Okay, 2 meter per second square. And let's make the question something. Find the acceleration of the trolley. Then second thing, all of you will do this question. Siddhisri, yeah, Siddhisri, you joined very late. Siddhisri,
Excuse me, sir. This is Siddhi's mother. She overslept,
yeah,
sir.
okay. Actually, yeah, I see most of the classes she comes late, so that's why.
Okay, okay. I will ask. I will talk to her. Thank you, sir.
Okay, okay. So okay. So your first question is, I think all of you have got the answer. Aman, you got the answer?
Yes.
Aman,
Yes, sir.
you got the answer?
Yes, sir.
Okay. So what's the answer for the first one?
2.
So see here we have the question. Part is what will be the yes. How many of you got the answer for the second one? What will be the acceleration if the ground offers a friction of 200 Newton?
Sir, is it 8/5?
Hmm. Yes. Now the acceleration would be 8/5. Okay. So here you have I produced third part also from here. How much time will horse take to attain a speed of 75 km per hour, 72 km per hour. Per hour, assuming no friction act on the trolley. So find this C part now. How much time will horse take to attain a speed of 72 km per hour, assuming no friction act on the trolley? And out of all the people, all of you who are present, is there anyone who has not understood any of these parts, A or B or C? I think you people are finding a problem in physics only. So mainly we'll revise first the physics wherever you are finding the problems. Okay. So quickly I tell you the answer since the class is about to over. So I tell you the answer. For the first one, your acceleration would be equals to force by mass. That's 1000 over 500, which you get as 2 meter per second square. For the second one, your net force will become 1000 minus 200. That is, you will have 800 Newton as the net force, and hence your acceleration will now be 800 over 500. That's 8 over 5 meter per second square. Okay. For the third part, how much time will the horse take to attain a speed of 72 km per hour, assuming no friction